Hello friends, welcome once more to class online. My name is Mr. Dami, and in this edition we shall be looking at Jamb Physics 2011, question number 16 to number 20, and we shall be super solving those questions in a way that you will find very easy to understand. Now let's get to the question. Don't forget that if you learn something from this series, click on like button. We have a lot to share with you that will better help you understand physics. Now let's get to the question. It says a block of aluminum is heated electrically by a 3-watt heater. If the temperature rises by 10 degrees Celsius in 5 minutes, the heat capacity of the aluminum is what? Now, this question is asking about heat capacity. Can you remember any formula on that? Now, if you don't, I'll remind you. Now, here is the formula. Now, you know, generally, we learn other time of physics. We learn that H equals MC change in temperature, right? Why the H is the heat, the M is the mass, the C is the specific heat capacity. Why this is change in temperature? That means this theta is temperature. Now, heat capacity itself is a combination, it's not heat. Heat capacity itself is a combination of mass and specific heat capacity. That means MC is your heat capacity. So I turn this MC into heat capacity and I use the symbol, this symbol. So H equals this, which is my heat capacity, change in temperature. So to find my heat capacity, I'll just bring this one under this one. So I'll make my heat capacity to become H over change in temperature. H, that's heat over change in temperature. That's my heat capacity. Remember, it came from MC, right? It became this, and this is my heat capacity. It is the combination of mass and specific heat capacity. That's MC, and that is it. So now, what's my heat? My heat now, in this question, we don't have heat, but we have power. You must also know that electric heat or electric energy is power times time. Now that is another thing to know. Electric energy is power times time. Now heat capacity is therefore instead of heat, it will become power times time over change in temperature. What's the power? 30 watts. The power in the question is 30 watts times the time is 5 minutes. But of course you have to change the time to seconds, and that will become 5 times 60 over the temperature below is in the question is 10 degrees Celsius. So I have 30 for power. The time is 5 times 60. That's now in seconds. It was 5 minutes, but times 60 makes 300 seconds. And therefore, I'll cause this now over the temperature is 10. So if I call this now, I'll be left with 3 times 5 times 60, and that will give me 900 joule per Kelvin. Or you can say 900 joule per Kelvin. It is both the same thing. So that is the answer for that question. C is the correct answer, 900 joule per Kelvin. Number 17, a power emitter or absorber of radiant energy is what? What kind of stuff emit or absorb radiation? Is it white body, red body, conductor, or black body? The answer is super simple. You can see this guy is putting on black, right? And why? Because when you now look at the base of your pot, sometimes if you cook with some stove that are not so good or that are not burning well, you have soot air pot. Because black color have been taught in science that black color help to absorb heat, as white color reflects heat. That's why the base of your pot is black with soot. Why is it black with soot most times? If the fire is not good, it will create soot under the base of the pot, and that should help the fire to penetrate the pot and cook food faster. That is the purpose, because it can penetrate light and dark or black body. Okay, now during rainy season, when it is cold, you should put on black clothes, and that has been explained to us in science that it will help to conserve heat, because black color help heat, produce heat, but white color reflects away it. So white color help to lose heat. So if you are putting on white color in rainy season when it is cold, when you need heat, then that person is not foolish. Bright clothes are not good for time when it is cold, because you need heat. You need black clothes to conserve heat. So that which absorb heat is black. It is a black body, and that is the answer to number 17. Number 18 said the phenomenon that shows that increase in pressure lowers the melting point can be observed in what? Now this is it coagulation, reduction, sublimation, or condensation? The answer is super simple. Now when we talk about this topic has been seen, we've learned this topic under when we're showing the effects of impurity, okay, and pressure on melting point and boiling point. And under that topic, we discovered an experiment called regulation, and that is the answer. Regulation is used to explain how pressure lower melting point. It is called regulation experiment. Now, and this is the way it goes. A fine wire with weight attached to both ends is hung over a block of ice. So if you put down the ice, maybe in the refrigerator, and you hang wire around it, you put a wire around it, and you put load around the wire on both sides of the block, and the wire is resting on top of the ice with high pressure. Okay, the wire will slowly cut its way through the ice. That means the wire, because it has pressure, it will begin to enter into the ice. Okay, but its track will be left full of ice. As it's going inside, the ice will be covering the part again. So now it will be entering the ice, and the ice will be closing back. And then at a point, if you come around, you will see that the wire has entered into the middle of the ice, but there is no path. That means the wire just disappeared from on top into the middle, because as the wire was entering, the ice was closing back. Okay, that is regulation, and that is to show that pressure exerted by the wire lowers the melting point of the ice, so that when it lowers the melting point, that part where the pressure is will melt and the wire will enter. And then when the pressure is gone, the wire and the ice will close back. So it will keep going on until the wire move through the ice and come down. So it has lowered the melting point through the ice, pass through, and escape under to the lower part of the ice. And that is what you are. This is called regulation experiment, and it shows that pressure lowers melting point. And that is the answer. The answer is simply regulation experiment. And that is the answer. Number 19 says, if the volume of gas increases steadily as the temperature decreases at constant pressure, the gas obeys what? Is it pressure law, Charles law, Grant's law, or Boyle's law? Do you have any idea? Now the answer is super easy. The answer is just this. Now look at this. If the volume increases steadily with temperature, okay. Now which of the laws have volume and temperature? Do you have any idea? Can you see that? Which of these laws, which of these gas laws have volume and temperature? Can you see that? Now Boyle's law says that what? Volume is inversely proportional to pressure. I just use this diagram to summarize because I love to summarize things. I love so much to summarize things. Volume, this is just Boyle's law in summary. Volume is inversely proportional. Volume is inversely proportional to pressure at constant temperature. This is just Boyle's law. Charles' law states that volume is directly proportional to temperature at constant pressure, and this is the answer. Charles' law has to do with what? Temperature and volume. So, and the question is that the volume of gas increase steadily as temperature decrease at constant pressure, and that is simply Charles' law, and that is the answer to that question. Grant's law says that what? Diffusion is inversely proportional to the root of the relative molecular mass of the substance, and that's Grant's law. But pressure law says that what? Pressure is directly proportional to temperature at constant volume. So you can put it down. This picture will remind you of all the gas law, the major gas law, without stress, without having to write a long note. And that is the answer. So the answer is simply Charles' law, and that is the answer to the question. Number 20 says steam burn is more severe than that of boiling water. Why? Why? Is it because now when you put your hand towards, if something is boiling, like this is boiling, if you put your hand towards the steam, if you cover this mouth with your hand, with your skin, it will definitely burn your skin. But that burn will be more severe. Why will it be more severe than putting your hand inside the boiling water? Do you have any idea? The answer is super simple. And the answer is this. Steam has more energy than boiling water. You know, energy increases with change of state. Solid bodies have lower energy because the molecules are not really moving actively. Liquid molecules are actually moving slowly, steadily. But gases like steam is actively moving, and that means it has higher kinetic energy. The molecules have higher kinetic energy, and that means steam is moving more actively than liquid itself, and that is the reason it possesses the additional latent heat of vaporization. Therefore, burn produced by steam are more severe than those produced by boiling water. Now the heat here is for normal heat, like the heat of boiling water, but it has an extra heat, and because the state is changing from liquid to vapor, it has an extra heat called latent heat. So it has the heat of boiling water. It also has an additional heat called latent heat of vaporization, and that is the answer. So the answer to that question is that steam is higher because it has higher heat than the boiling water. It has an extra heat called latent heat or vaporization. So the answer is simply steam possesses greater energy. Of course, heat is energy per unit mass, and that is the reason why steam burn is more severe than boiling water. And that brings us to the end of this series. Don't forget that if you learn something from this video and you want to get more content, click on the like button, and we have a lot to share with you that will better help you understand things. Until we see you again, take care of yourself and bye for now.